Okay, so in the learning outcome, you can see over here what should you know and learn in this hour. Okay, in this subtopic. So you need to define what is a buffer solution. First of all, is definition. And then you need to describe how a buffer solutions control its pH value. Okay, so it means the function, how it's control the pH. And then we need to write the Henderson-Hazard equation for a given buffer solution. So for the learning outcome K over here, that means you have a specific formula for each question. All right. And then the last one is to calculate the pH of the buffer solution using the Henderson-Hazard equation. And then we have two scenario, which is before the action, okay, before its function, and after the function of the buffer solution, which is you're adding extra acid or you add extra base into this buffer solution. Okay, so here is the learning outcome. So first of all is the definitions of buffer. So a buffer solutions is a solutions that can maintain its pH value. Okay, maintain its pH value when a small amount of strong acid and strong base is added to it. So over here, sometimes you can say over here a solution that resists the pH change. Maksudnya kalau kita ada tambah strong acid ke strong base ke, perubahan pH dia tak banyak, tak ketara, dia sikit sahaja perubahan dia. Okay, that's why we say resist the pH change or maintain its pH value. Okay, resist pH change. And then you must remember that it will only when you are adding the strong acid or strong base. So a very common one, strong acid, we have HCl. Then the strong base, we have NaOH. So this buffer solution, you need to know about the content. What is content inside this buffer? So a buffer solution is a mixture of a weak acid or weak base. Okay, weak acid or weak base with the salt that containing its conjugate pair. So let's say if you're having weak acid, then you are having the salt containing the conjugate base. So weak acid and conjugate base. So ini adalah satu pasangan. Okay, and then if you're containing weak base, then it will together with the salt that containing its conjugate acid. Satu pasangan. Weak base, conjugate acid. Okay, so it categorized into two types of buffer. We have acidic buffer, we have basic buffer. So let's look at the first one, acidic buffer solution. So in this acidic buffer solution, so the word acidic itself show you that it contain a weak acid. So ini adalah dia punya karakter yang pertama, contain yang pertama. Acidic buffer contain weak acid. And at the same time, it containing the salt that has the conjugate base. So macam confuse kan, madam, sekejap acid, sekejap base, apa yang kita nak maksudkan sebenarnya. Okay, so let's look at the examples. So let's say in this acidic buffer solution, in this mixture, we're containing a weak acid, which is your acetic acid, CH3COOH. And then this is the salt, CH3COONA. So in this CH3COONA contain CH3COO minus, which is the conjugate base. So you can actually write on top of here, this is your weak acid. Okay, this is your conjugate base. Or you can also write as the salt. Salt, conjugate base, they refer to the same thing. Why do we say so? Look at the equation. So we have the partial dissociations of weak acid. Kena ingat weak acid partial dissociation ataupun dia punya dissociation is only very slightly. So dekat sini akan ada satu reversible arrow. So let's write this way. CH3COOH, the weak acid. So when it dissociate partially, that means this system is in equilibrium. So it will producing your CH3COO minus, the conjugate base, and also the H plus aqueous. Let's say if you use the equation, you add in water, therefore you are producing H3O plus. So apa yang kita belajar sebelum ni lah untuk partial dissociation. So is everyone good until this point?
Yes, madam.
Yes, madam.
Alright. So sambil madam tulis, awak pun catat dalam nota awak ya. And then the other content of this mixture is the salt. So recall in your previous the egg puzzle in the earlier morning just now. Salt is completely dissociate. So when a salt completely dissociate, arrow dia single direction sahaja. Okay, so in this case we have CH3COONA, the salt. So complete dissociations to give you CH3COO minus and also the Na plus. Okay, so you can see over here we have the conjugate base. Why we say the salt must containing the conjugate base? Maksudnya dekat salt ini dia mesti kena ada conjugate base daripada acid dia. So ada weak acid, ada conjugate base. So take notes or highlight on the arrow. So you must be very sure about why we are using this arrow. So until this point, is there any questions? Ada soalan?
Tak ada, madam.
Okay, tak ada Madam pekat I just realized over here actually got something else. Let me see what is underneath here. Oh, ada dulu dekat sini Okay, so you need to identify what is the acidic species and the basic species containing inside this buffer solution. So tadi Madam cakap dalam buffer dia hanya ada dua benda saja. Dia ada weak species dekat sini, case ini adalah weak acid and also the salt. So inside the salt containing conjugate base. Dengar baik-baik conjugate base adalah salah satu base. Okay, so in this buffer solution, your acidic species, of course, it will be your weak acid. So kita tulis dekat sini. Identify the content first. And then in this buffer solutions also we containing the basic species, which is your conjugate base, COO minus, which is dissociate from the salt. Okay, hasilan daripada awak punya complete dissociations of salt. So catat dulu acidic species, weak acid, basic species, conjugate base. Awak letak kat belakang dia punya terms pun boleh, weak acid, and then over here is the conjugate base. Okay, so just now we say that the function of this buffer is to resist the pH change, to maintain the pH value. So this one refer to our buffer action. Ataupun macam mana kita nak tunjukkan function buffer solution ini. Kita panggil dia sebagai buffer action. And then we want to see how is it maintain your pH change. Okay, so there is two scenario. In the first scenario over here, if I try to add a little bit of strong base. So for example, if I add NaOH, KOH, LiOH, and etc., the strong base, into the solutions here, into your beaker that containing your acidic buffer. So you need to identify which species will come to neutralize this strong base. So common sense, acid base will react. Acid and acid, they won't have reaction. So kalau kita tambah strong base, siapa yang akan datang untuk neutralizekan NaOH ini?
Weak acid.
Weak acid. So awak hanya ada dua pilihan saja. You only got two choices, weak acid or conjugate base. So just now Madam say base and base cannot react. So over here, your weak acid will try to neutralize this strong base. Okay, so fill in the blanks over here. The choice in this acidic buffer is the weak acid CH3COOH. So acid-base neutralization. Okay, and then I leave a blank space over here for you to jot down. So OH minus is the one that we added, the extra one. And then when it neutralized by this weak acid, Remember that neutralization is a complete reaction. Neutralization acid base dia adalah complete reaction. So dia akan dapat satu arrow saja, single direction only. So OH minus accept one proton from your weak acid to become HO2 liquid. Okay, and then you have the product after the CH3COOH donating the proton. Sebab kenapa donate? Kalau awak tengok dekat sini, H ini dia pindah kepada OH minus to produce the water. Therefore, now your product is left with CH3COO minus aqueous. Do you get me?
Yes.
Okay, mesti kena tahu macam mana nak lukis, tulis equation. So OH minus, the added strong base, react with your weak acid. So produce the conjugate base CH3CO minus and H2O. All right, and then after that we want to do explanation. So as the concentrations increases, so if you're producing more CH3COO minus, the concentrations will increase. So Madam highlightkan untuk awak dekat sini. So now we are talking about this concentration. So the concentrations of your conjugate base increases. So we want to look back at the equations over here. So if your concentrations of conjugate base increases, kita patah balik kepada equation yang Madam bulatkan dekat sini. Do you see which one I'm highlighting? Madam highlightkan So I'm highlighting over this column. Do you see it?
Yes.
Okay, so you look at the concentrations that I highlight in yellow, concentrations of the conjugate base. Kalau dia meningkat, increases, the concentration increases. Where is your equilibrium shift to? Left or right?
Left.
Left. Okay, it will shift to the left as the concentrations of your conjugate base increases. So equilibrium position shift to the left to replace the amount of weak acid used. Sebab kita guna weak acid untuk neutralizekan strong base added, right? So we want to replace the amount of the weak acid used. Therefore, when your equilibrium shifts back towards the reactant side, you're actually maintaining the concentrations of both species. Reaction between strong base and weak acid, dia hasilkan lagi banyak conjugate base. But then at the same time, equilibrium would try to lower down the concentration. So it tried to maintain the equilibrium. So we will say that the pH value is not much affected. Dia akan berubah, tapi dia berubah sikit sahaja. Kalau tambah base, you added base, supposedly the pH value will increase. But in this case, it will only increase just a little bit. So this one is in theory. Later we will see the calculation. So for the first scenario, is everyone okay? Is there any questions? Ada soalan nak tanya?
No, madam.
Tak ada, madam.
That's okay, yeah? All right, so we proceed to the second scenario. So in the second scenario is when you want to add a small amount of strong acid. So in this case, H3O plus, H plus, or maybe I gave you HCl, the common strong acid. Okay, so when HCl is added, which species will come to neutralize it? You only got two choices, weak acid or conjugate base.
Conjugate base.
Conjugate base. So dalam example ini, conjugate base kita adalah CH3COO minus. So base, acid react together. So we write our equation. So madam using H3O plus lah. If you want to use H plus, no problem. Normally I will use H plus lah, simpler. But since here give you H3O plus, so I'll use H3O plus, yeah? So it will react with the CH3COO minus, the conjugate base. And then Neutralization is complete reaction to give you CH3COOH aqueous. Okay, and then the H3O plus after removing one proton, it now remains H2O liquid. So dekat sini ada sesiapa ada masalah tak untuk tulis equation? Can you follow? Boleh ikut, madam?
Yes,
Boleh,
madam.
madam.
Okay ya, kena pastikan
Boleh,
acid react dengan base. Okay, acid react dengan base ini penting. Okay, so now we look back over here. Again, madam highlight for you. Now we are producing more acid. Okay, so maksudnya concentrations of this weak acid increases. So we write back in the sentence. So concentrations of the weak acid CH3COOH increases. But remember, this is the weak acid. So weak acid has a very, very small dissociation. Therefore, we will say the most of the acid remains as the CH3COOH. Dia punya compound. Dia tak ada pecah jadi H+. Okay. So if we go back to the one that highlighted in blue color, we come back to this one again. Since the dissociation is very small, therefore your pH value will be maintained, or pH value will not much affected. Okay, so dekat dia punya theory in its explanation, it depends which one you are reacting. Ada masa dia kalau dia produce conjugate base, then we talk about equilibrium shift. Okay, if you talk about the weak species, weak acid, then we talk about the dissociation. So dekat sini awak boleh highlight kan dia punya key idea. So over here, madam highlight kan. If you talk about conjugate base, equilibrium position. You talk about the weak acid, we talk about the dissociation. So dekat sini memang kena baca beberapa kali untuk fahamkan buffer action. So this is the theory. Okay, so for the first scenario, second scenario, any questions? Ada soalan?
Tak ada, madam.
So far tak ada ya. Okay. Then we look at the last row over here, Henderson-Hazard equation. So this equation is very interesting. It will only for when you want to find the pH value for acidic buffer solution. So madam ajar awak macam mana nak kenal. Kalau awak sudah pastikan solution ini adalah acidic buffer, then you check, I must use this equation. pH, H stand for acid, Ka stand for acid, and then on the bottom over here we have weak acid. So Pa, pKa, and then log. On the top is your conjugate base, or maybe sometimes you can fill in with the salt because they have same concentration. Okay, and then on the bottom you have weak acid. So if let's say I'm using the same example on the top here, so pH equals to pKa. In the earlier lesson that you learned, that is equals to negative log Ka. So you can straight away use this one to do substitution. Negative log Ka plus log. On the top, we have the conjugate base. So dekat soalan ini, dekat example ini, CH3COO minus. And then over your weak acid, CH3COOH. So for every different questions, they have different equation. Sebab formula untuk species dia berbeza. Mesti kena guna yang specific formula. Jangan guna yang general formula. Ini adalah general, kita tak nak. Kalau dia adalah written exam, we will use the specific formula. Do you get me? Is everyone good?
Good.
Yes, madam.
Okay,
Good,
so
madam.
let's proceed for the buffer one. Okay. So for the basic buffer, basic is say that we were having the weak base in the mixture. So weak base and the salt that containing the conjugate acid. So you will see that is a pair, weak base, conjugate acid. So a basic buffer, of course, the pH value basic, right? It should be more than 7, but slightly more than 7 only. So giving you the examples over here, we have the weak base NH3. You will want to write down over here, and then the salt that containing the conjugate acid. So in this case, the conjugate acid is your NH4 plus. So let's write the partial dissociation of your weak base NH3. Okay, so remember that weak base, when you want to do these partial dissociations, you must add in water. So you can get a complete and balanced equation. So in equilibrium, to get your NH4 plus aqueous as the base accepting proton. And then the H2O will losing proton to become OH negative. Okay, again, highlight the arrow. Menda tolong highlightkan, awak pun ikut juga highlightkan awak punya arrow. So weak acid, weak base, you have the equilibrium arrow. And the next one, we have the complete dissociations of salt. In this case, the salt given is NH4Cl. Imagine just write aqueous because it is the salt solution. So kita letak AQ sahaja. And then when it dissociate completely, take notes on the arrow. It gives you NH4 plus aqueous and Cl minus aqueous. Again, highlight the arrow. Okay, so can you follow until this part? Am I going too fast?
No,
Boleh ke,
madam.
madam? Boleh
Boleh,
ya?
madam.
Okay. So tell me about, in this buffer solution, which one is your acidic species?
NH4 plus.
Very good. NH4 plus. So NH4 plus, even though it's just a conjugate acid, it is still an acid. Okay. And then how about your basic species?
NH3.
NH3, of course, you contain the weak base. So dekat belakang boleh tulislah weak base. Okay, so now back to the buffer action. We want to show the functions of this basic buffer. So again, we start with the what we call it. We start with the additions of strong base, OH minus. Okay, so in this case, OH minus is added, strong base is added. Which species is coming to neutralize it? Is it NH4 plus or NH3?
NH4 plus.
NH4 plus. Your conjugate acid will neutralize the strong base. Okay, therefore write the equation. So added strong base, right? OH minus. And then you have your conjugate acid. What arrow are you using? Single or reverse? What arrow is using? Is it single or reversible arrow?
Single.
Single. Why single? Why is it single?
Complete
Why is it single?
dissociation.
It is neutralization. So neutralization acid base, it is single direction. Okay, complete reaction. So OH minus NH4 plus will give you the product NH3. So after the NH4 plus donate proton, right, it become NH3. Okay, and then the products, you have water. Okay, so highlights again. In this case, we are producing the weak species. So just now, madam say, if it mentioned about the weak species, we talk about the dissociation. Okay, so of course the explanations madam give you, but you need to practice write out the full sentence. Yeah. Then we need to explain further. Since the concentrations of your NH3 increases, but the dissociations is very slightly. The dissociations of NH3 is very small. Therefore, your pH value is not much affected. So far, so good. If you have any questions, you don't want to ask it, you can type it into the message column. So ada soalan? Tak ada soalan, Madam continue. Is it good?
Good,
Yes.
madam.
All right. So the second scenario over here, we have adding small amount of strong acid. So which species will come to neutralize it?
NH3.
NH3.
NH3, because acid-base neutralization. So NH3 will neutralize the added strong acid. So in this case, H3O plus is neutralized by your weak base in this buffer and complete reaction single arrow to produce NH4 plus and also your water. Okay, so when we talk about the conjugate pair, so in this case, you have the conjugate acid. Conjugate acid, you mentioned about the equilibrium position. All right, so since your concentrations of conjugate, conjugate acid increases, the equilibrium positions will shift to the left or right?
Left.
Okay, kalau untuk explanation equilibrium shift, you need to look back at the first equation, the very first equation that we using. So dekat sini Madam bulatkan ya. Okay. So if the concentrations of your conjugate acid increases, equilibrium will shift to the left to replace the weak base that you have used. So just now we're using the weak base, right? So we want to replace it. So the equilibrium shift to the left to replace the amount of NH3 used. This sentence might be a little bit complicated, but you need to read through a few times and then refer back to the equation. Dan cuba ceritakan balik apa kaitan dengan buffer action. Okay, so we will say that the pH value of the solution is not much affected. The Henderson-Heisenberg equation, for this case, we have the basic buffer solution. So the equations will refer to POH. So basic POH. So we have this OH. Tengok pada Henderson-Heisenberg equation ya. Basic buffer, we use this equation. POH, PKB. And then on the top, you have conjugate acid or the salt. And then on the bottom, you have your weak base. And then after you get your value of POH, you need to convert back into pH. So kita cuba untuk keluarkan equation untuk example ini. So POH equals to negative log KB. Okay, plus log conjugate base, conjugate acid. What is it, the formula? For this example.
NH4 plus.
NH4 plus. Or maybe you want to write as the concentrations of NH4Cl can also, because salt and the conjugate acid has the same concentration. So tak ada masalah. Dua-dua betul. And then after that, you have your weak base in this case. So here is the specific equation for the example here. So until this part, is there any questions? Ada soalan?
Tak ada, madam.
Tak ada, madam.
Okay. So this two page for acidic buffer, basic buffer is actually the whole content, the whole theories already. So we want to look at the example questions. So in the notes, Madam gave you 3 questions to calculate the pH, and then the buffer solutions, we have 2 questions. Okay, so for now, Madam think Madam cubalah tengok boleh habiskan beberapa soalan, dan soalan yang seterusnya akan sambung dalam awak punya practical session. So for MS8 will be this afternoon 2 to 4, and then for MS9 will be tomorrow, MS7 will be on Thursday. Okay, then let's start with your calculation. To get ready with your paper, you need a piece of paper. The working set is it's not very long, but slightly needs some space. So in order to calculate for this pH value for a buffer solution, first you need to determine what is the type of your buffer. Is it acidic or basic? Okay. And then after you determine the type, you need to choose the correct equation. Are you using pH or using pOH? So you choose. Okay, so in your first examples over here is quite straightforward. We start with the easiest one. This is the first scenario. Okay, this is the first scenario if no volume is given. Okay, if no volume is given. But then there is concentrations of your weak acid, or weak base, and the salt. Okay, so let's look at these questions. Calculate the pH of buffer solution composed of 0.12 molar benzoic acid and 0.20 molar sodium benzoate. And then you are given the Ka value. So let me know, is this an acidic buffer solution or basic buffer?
Acidic.
Why is it acidic?
C6H5COH benzoic acid.
Okay, so you're containing weak acid and the salt that containing is conjugate base. Betul? So kena identify dulu. Dia adalah acidic buffer. Kalau takut lupa, boleh tulislah acidic buffer. So when you write already, you can come up with your specific Henderson-Hazlitt equation. So we have pH equals to pKa, which is negative log Ka, plus log, what should I write on the top?
Conjugate base.
The conjugate base or the salt. So C6H5, COO minus or COONA, both accepted. And then on the bottom will be your weak acid COOH. And then you just substitute the values. Okay, because no volume is given. So concentration straight away. Don't forget that the square bracket represents concentration. So negative log Ka, substitute the value 6.3, 10 to the power of negative 5. And then log, we have concentration salt on the top, given that 0.20, and then acid 0.12. Okay, cuba kira. Okay, cuba kirakan awak punya pH value.
$4.42.
4.42. How about the others? Do you get the same value?
Yes, madam.
Dapat Tolong kira tau. You punya calculation mesti kena kira. Okay, cubakan macam mana nak masukkan value Ka, macam mana nak masukkan log, macam mana nak key in value fraction. Okay, so in this case, you got 4.42. So you need to remember that for strong acid, strong base that have one pattern, calculation pH value got one pattern. Weak acid, weak base, we need to use the ice table. Dia ada satu pattern sebab dia ada Ka, Kb, kena cari quadratic. And then this is for buffer solution. So every time when you got a solution, identify first what you want to find. Is it a strong species, weak species, or is it a buffer? So equation dia semua berbeza. Kena pastikan awak faham ya. So clue untuk buffer, tengok mixture, ada mixture tak? Ada weak acid dengan salt. Kalau ada dua-dua benda ni, dia adalah mixture, dia adalah buffer. Okay, so we proceed to the second questions. Alright, this second question is the second scenario. Second scenario whereby you have both solutions given the volume. Ada dua volume dekat sini. Concentration pun dia bagi, salt concentrations, the weak acid, weak base concentrations. So you need to take notes on the volume. Okay. So the question says that you need to calculate the pH value given 25 ml of 0.02 CH3 and H2 mixed up with 50 ml of 0.01 molar CH3NH3Cl. Tell me about which buffer. What type of buffer solution is this?
Basic buffer.
Basic buffer.
Basic. Okay, because we're having a weak base, we're having the salt that containing the conjugate acid. Kalau tak faham boleh catat dekat sini. Kalau sudah faham tak ada masalah. Yang penting awak kenal, pastikan dia adalah basic buffer. Okay, so now if you look at the diagram, I didn't draw a simple diagram for you. Say this one is my CH3NH2. I got 25 milliliter initially. And then for the salt, CH3NH3Cl, I have 50 milliliter. Is this two container buffer? Is the diagram Madam draw over here a buffer? Yes or no?
No, belum campur lagi.
Because it's not. It is separated.
It is separated. So this one is still your weak base. This one still your salt. So dia belum jadi buffer lagi. So maksudnya dekat sini is mixed up. So that means you need to combine both solution. You have your CH3NH2, CH3NH3Cl in the same container. So that means now the total volume becomes 75 milliliter. Then this will be your buffer. Do you get me? So kena pastikan soalan minta apa Kalau dia hanya minta acid punya ni base punya pH, cara kira dia lain. Kalau dia tanya buffer, kena pastikan dia sudah campur ke belum. So in this case, it have already mixed up. So we need to figure out the concentration after both solution is mixing. Because if you look at this one 0.02, this one is before mixing. So Madam tulis kat sini 0.02. Yang ini 0.01 mula untuk salt. So awak kena cari. Selepas dia sudah campur, concentration yang baru dia adalah apa? So what formula are you using if I want to find the new concentrations after mixing? Any idea what formula am I using?
M1 V1 equals to M2H.
Very good. M1 V1 M2 V2. So if you don't know how to do it, maybe similarly you can do the same diagram like Madam. So you can see, oh, this is my first volume. This is my first concentration. So I have the second volume. Then what is my second concentration for the base? What is my second concentrations for the salt? So we need to do it two times lah for the salt as well as the base. All right, so let's just do this one. So using the formula N1 V1 equals to M2 V2. So figure out your new concentrations for the base first. So Madam tulis kat sini. 2 maksudnya dia selepas mix up. Okay, so initial concentrations of the base 0.02. The volume is 25 milliliters. Then the new volume after mixing 75. So what is your new concentration for the weak base? Can you follow up until this part? Boleh ikut?
Yes, Madam.
Boleh ya? Okay, dapat berapa concentrations?
0.0067.
Okay, 0.0067, or if you want to write in times 10 to the power of something, you got this value. 0.0067 accepted as well. Okay. And then after that, you need to figure out the concentrations of the salt. So CH3 and H3Cl. Okay, and then we have the initial concentration 0.01. Okay, and then initial volume 50, final volume 75, which also give you the same value. So tak ada masalah lah kalau awak dapat 0.0067. Alright, so The next part is just to substitute into your Henderson-Heisenberg equation. So just now we said this is a buffer, a basic buffer. So what formula am I going to use?
POH.
POH.
POH equals to negative log
KB.
KB plus log on the top concentrations of your salt or concentrations of your conjugate acid. Then on the bottom you have your base NH2. Pastikan formula adalah betul ya. And then just substitute the value. Negative log value given KB 4.4. Tengok balik pada awak punya soalan 4 10 kuasa negatif 4. So that's KB. And then log concentrations, we have got the same concentrations for the salt and the base. So awak akan dapat log 1. Log 1 sama dengan kosong. So sebenarnya awak kira negative log KB sahaja. Okay, so in this case, the values of POH, you will get 3.36. So madam bagi jawapan, awak tolong kira pastikan awak practice. Is this my final answer?
No.
No, and I should get a pH using 14 minus your POH, and your final value should be 10.64. So of course, pH more than 7, it indicates that this is a base, a basic buffer. Okay, so the calculation given. All right, so any questions for questions number 2?
No, madam.
No, madam. Everyone's clear, yeah? Can follow. Do you think it's easier? Slightly easier? Can follow?
Yes, can follow. Can.
Can follow. Okay.
Yes.
Nak cari pH untuk buffer dia senang. Tengok dia punya concentration selepas dia campur. Okay, the difficult part will be buffer action. Okay, so buffer actions, madam has already recorded the video, just belum siap edit lagi. Okay, once I edit, I will post it up into the app puzzle, especially for MS8 this afternoon. So this afternoon, MS8, it will continue for question 3, and then question 4 and 5 for buffer action. So complete that one. If you can't understand, doesn't matter. In the next tutorial class, you may raise up what is your problem, macam mana tak faham, madam, part ini saya kurang faham sikit. You can always ask questions. So just to remind you again, practical sessions will be through app puzzle. Okay, for MS7, MS8, and MS9. MS32, madam will arrange. I will ask Encik Mazlan whether I can take over their 1 hour, his 1 hour or not. So I will update you again, as your practical session will be tomorrow morning. So madam will update MS32 in a while, yeah. Then for your tutorial class, the next individual tutorial class will be face-to-face or hybrid. So akan masuk kelas. Okay, so maksudnya untuk MS8, MS9 esok petang. MS32, MS7 will be on Thursday. Is everyone clear?
Yeah.
Yes.
Kalau clear, sebenarnya selepas 2 soalan ini, awak boleh cuba dulu exercise yang ada dekat sini. Contohlah exercise 4 ni, soalan 1 dah boleh, sudah boleh buat lah. Soalan 2 pun boleh, soalan 3. Sampai soalan 4 pun awak sudah boleh buat. Cuma ada buffer actions macam 4B, 5B. 4B boleh. 5B hold on dulu sebab 4B adalah calculation buffer action. So that one you haven't teach you yet. So soalan 1, 2, 3, 4 awak sudah boleh buat dah. Okay. So now Madam share you the link for the assessment and the attendance. Okay, so the link, you can get it from the in-call message over here. So there's 4 questions and answer accordingly ya. Dia punya content adalah apa yang Madam ajar waktu ni. Okay, so before we end our session, is there any questions you would like to ask?